So, hi guys, I'm back with a new topic that is your time complexity and space complexity with algorithms. So, basically, I just wanted this topic because when you're going for interviews, again, respective of experience, people can ask, what is the time complexity? How do you calculate for a given program? And what is the space complexity? Most of the BTech CS people would know, but I just wanted to make this for all the people like who are from electronics or and do job in engineering. They should know about it. So let's start. We'll start with space complexity. So when we talk about space complexity, we say that whenever we write a code, algorithm is basically steps to solve a program. So basically, we are writing a step of code. Like for example, so here this is an algorithm to sum of n numbers. So whatever the extra space I am giving to like extra variable or something like that, that will be a space complexity. And time complexity is the time required by the algorithm to you know execute this basically function, basically algorithm. So time complexity is about how much time that will take, and space complexity is about how much space it would take. Let me explain with an example so that you can understand it very clearly. For now, for example, suppose I'm writing an algorithm for sum of n numbers. So I have written this function. We'll call this from main by giving an input. So we are giving a int n, a fixed amount of space. That is your constant space. Then we are doing this. Then we are taking the loop. So it this algorithm or this function will take constant space complexity because it's a size of one. Basically, if it is an array, then it can be the space complexity will be the size of array. Okay, and what is the time complexity? Up now, when we talk about time complexity cannot be just said like that. This is like n. There are some there are some metrics like we measure length in meters. Similarly, space and time complexity can be measured in three ways. That is your three scenarios basically: best, average, and worst. Best is your omega notation. Best time complexity as it is represented by this. Best means the least time taken to execute that algorithm. Average is something which says that this is uh, average means on an average the time taken by the algorithm. And the worst is the maximum time taken. So out of these scenario, we usually take calculate the time complexity and the space complexity in worst case time. Why? Because when we write an algorithm, we need to check what is the maximum time it is taking and how we can improve it. So always look for tell the time complexity in big O notation, which is represented by this big O of one, theta of one. For example, if I am being asked for this question, what is the time complexity? So I would write as big O of n, and what is the space complexity? Big O is the worst case. So this is your space complexity, and this is your time complexity. This is one of the very basic example I'm explaining. I'll bring videos if you want on a lot of ways how you can calculate time complexity and space complexity. It's just a basic abstraction video over this. So basically, they can ask you what is time complexity, what is space complexity, what are the different ways metrics by which we can calculate time complexity. Then we'll have a look over what type different type of complexities and their meaning. For example, if we talk about with given input size n, the time complexity will vary. Some will give less in less time they will give the outputs like log n log n square, exponential, and factorial. So as they move towards this, the time complexity increases, so as the performance of the algorithm decreases. So we should always prefer, till this line. These are okay. N log n or big O of n. See, it is shown. Big O of constant. Big O is best. Log n is good. Fair enough algorithm. and log n is bad, and expansion factorial is the worst time complexity. I mean, if you're writing an algorithm which is having factorial complex time complexity, it is not a good algorithm. It will be only good when its time complexity is log n. For example, let us take an example of linear search. We know when we do a linear search, we have a time complexity of big O of n. When we do a binary search, we have a time complexity of log n. So why binary search is preferred? Because of its worst case time complexity is log n. It means that again in the worst scenario, binary search will give us our result in log n time, whereas linear search will take n time. If there are 100 inputs, they will take 100 times. Log to the power 100. It will be a very small number as compared to your linear search. Thus, binary search will be preferred. That will be all. If you like my video, do let me know, like, subscribe, and do comment. Thank you. Bye bye.